Good morning, children. We'll continue with the problems. Now, you are given A is a non-zero vector and then B, C are two vectors such that A cross B is equal to A cross C. So, you are given first problem solution we are writing. A is a non-zero vector. A is a non-zero vector. A is not equal to zero vector. It is a non-zero vector. And then A cross B is equal to A cross B is equal to A cross C is given. So these are all given. And then what is given? A dot B is equal to A dot C is given. You must show that B is equal to C. So what we do is, now we'll take this. A cross B is equal to A cross C. So we'll take to this side. A cross B minus A cross C is equal to 0. Is equal to 0. So now we know the distributive property, no? So it is A cross of B minus C is equal to 0. Because it is like this, we are writing the distributive property. When you expand, you are getting the same thing. So A cross B minus A cross C is 0 like that. So it implies that when cross product of two vectors is 0, this implies that either A is 0, implies either A is 0 vector, A is 0, or B minus C is 0 vector, or A is parallel to B minus C, or A is parallel to B minus C. These are the three possibilities. Now we'll take this. A dot B is equal to A dot C. In the same way, again A dot B is equal to, again we are given A dot B is equal to A dot C. In the same manner, when we simplify, it is A dot B minus A dot C is equal to 0. So it is A dot of B minus C is equal to 0. So we'll do one thing. We'll number this as 1 and okay. Now this implies either A is 0, either A is 0 or B is 0, B minus C is 0, B minus C is 0, or when is the dot product 0? When they are perpendicular. So A is perpendicular to B minus C. These are the possibilities. So from the first equation given, you are getting three possibilities like this. From the second equation given, you are getting three possibilities like this. Either A is 0 or B minus C is 0 or A is perpendicular to B minus C. Among these two, what is common which is satisfied by both the equations? These two equations satisfy only one common condition. What is it? It is this property. A is not equal to 0 is given. So A cannot be 0. And then it cannot be perpendicular and parallel at the same time for B minus C. So these two are not possible. Only B minus C is equal to 0. So we'll write from 1 and 2 we get, from 1 and 2 we get B minus C is equal to 0 because A is not equal to 0. This is also common, but it is given that A is not equal to 0. So it has to be this. So this implies that B minus B is equal to C. Hence it is proved. So like this we do this problem. Okay. Now the second one is again very important problem. You are given A and C two vectors. Find the vector B such that A cross B is equal to C. So you are given A is equal to I plus J plus K. These are all given. I'll write given. Given A is equal to, then C is equal to J minus K. And then what else given? A cross B is equal to C. And then A dot B is equal to 3. You must find such B vector. So what you do? You take B vector as some xi. Generally, the unknown vector is always taken as xi plus yj plus zk. Xi plus yj plus zk. Now, A cross B is equal to, first I'll take A dot B. A dot B is equal to 3. Implies what? What is A? A is I plus J plus K. I plus J plus K dot of B. B is xi plus yj plus zk. That is equal to 3. Is equal to 3. Now take the dot product. You know, you should multiply the x coefficient, I coefficients, j coefficients, k coefficients and add. So it is x plus x into 1 plus y into 1 plus z into 1. X plus y plus z is equal to 3. So we'll number this equation as 1. Now we'll take this a cross b. First we'll find a cross b and then we'll equate it to c. A cross b is I, j, k. A is 1, 1, 1. B is x, y, z. Now you expand the determinant. So you'll get I into z minus y. So z minus y into I minus j into z minus x. Z minus x plus k into y minus x. Y minus x. So if you have learned the method, you can directly write the determinant. You need not write bar determinant of 2 by 2 matrix like that and then find the value. So you got like this. Now what is given? You are given a cross b is equal to c. So now we'll take a cross b is equal to c. So you are given a cross b is equal to c vector. So what is a cross b? A cross b is this. Z minus y into I minus j into z minus x minus, I'll write z minus x into j plus y minus x into k. Y minus x into k. So this is equal to, we'll write k here, j also here like this. Equal to c. What is c? J minus k. That means it is 0i plus 1 into j minus 1 into k like this. Now these I, j, k are non-coplanar vectors. Since I, j, k are non-coplanar, you can equate the corresponding coefficients of I, j, k. So that means z minus y is equal to 0 and then minus z, minus of z minus x, that is 1, and then y minus x is equal to minus 1. So these are the equations. Now you must solve them for x, y and z. So this means y is equal to z and here you will get minus z plus x is equal to 1. So that means x is equal to 1 plus z and here you will get y is equal to x minus 1. So these are the equations. Now you have y is equal to z and also x is 1 plus z. Both y and x are in terms of z. So we'll take these two equations and substitute here, we'll get z. So I'll number this equation as 2 and this as 3. This is 4. So substituting 2 and 3. Substituting 2 and 3 values. Substituting y is equal to z and also x is equal to 1 plus z in 1. We get x plus y plus z. X is what? 1 plus z. 1 plus z plus y. Y is also z. X is 1 plus z. Y is z. Z is z only. So you write z only. That is equal to 3. So take 1 to that side and all. So you will get 3z is equal to 2. So z is equal to 2 by 3. Z is equal to 2 by 3. Now y is equal to z now. So from 2 you will get, from 2, equation 2 you will get y is equal to, z is equal to 2 by 3. And then from 3 you will get, x is equal to 1 plus z. 1 plus 2 by 3. So that is 5 by 3. Now you found all the values. You can substitute here and check whether your values are correct or not. So 5 by 3 minus 1 is 2 by 3. It is correct. So now you substitute in the vector b. All the values of vector b. So therefore b is equal to xi plus yj plus zk. So what is x? X is 5 by 3. So is equal to, so it is equal to 5 by 3i xi plus yj. So 2 by 3j yj plus zk. Z is again 2 by 3. So plus 2 by 3k. So this is your answer. You can take 1 by 3 common and write the answer in that form. So like this we do the problem. According to the conditions, we just simplified and substituted. That's all. So it is very simple. Yeah, now we'll continue with the next problem. Now next problem. A, B, C are unit vectors such that A is perpendicular to the plane of B and C. A and B are unit vectors. A, B, C are unit vectors. So you have like this. A vector is here. A is perpendicular to the plane of B and C. So B and C are in this. And then A is perpendicular. A is perpendicular to the plane of B and C. And the angle between B and C is pi by 3. Angle between these two vectors is pi by 3. Suppose I draw vector like this. The angle between them is pi by 3. This is given. Find mod of A plus B plus C. As I explained, whenever you have mod of A plus B plus C, always find mod of A plus B plus C whole square and do it. So, A, B, C are unit vectors. So, third problem solution. A, B, C are unit vectors. So, you are given mod A is equal to 1, mod B is equal to 1, mod B is equal to 1, mod C is also equal to 1. And then A is perpendicular to both B and C means A is perpendicular to B, A is perpendicular to C. So that means their dot product is 0. A dot B is 0 and this implies A dot C is also equal to 0. Angle between B and C. Angle between B and C is pi by 3. Pi by 3 means 60 degrees. Okay, now we'll find mod of A plus B plus C whole square. To find mod A plus B plus C, we always find square and then take the root. So it is A plus B plus C dot of A plus B plus C. So you know the formula, mod A square plus mod B square plus mod C square plus 2A dot B plus 2B dot C plus 2C dot A. This is the formula. So you know mod A as equal to 1, BC also as equal to 1, 1 square plus 1 square plus 1 square plus A dot B is 0. So substitute it is 0 plus 2B dot C is again 0. A dot B is 0. B dot C we don't know. So we'll write 2 into B dot C plus C dot A or A dot C is 0. So this is 0. So this is 1 plus 1 plus 1, 3 plus 2 into B dot C. Now we'll write the formula for B dot C because we don't know the value of B dot C. So 3 plus 2 into mod B into mod C into cos of angle between B and C. What is angle between B and C? 60 degrees. So now just substitute the value, simplify, you will get the answer. So 3 plus 2 into mod B is 1, mod C is also 1. Cos 60 is half. So 1 by 2, 2 and 2 gets cancelled. So it is 3 plus 1, that is 4. So mod A plus B plus C whole square is equal to 4. So therefore mod of A plus B plus C is equal to root 4. Root 4, that is 2. So this is your answer. So like this we do the problem. Now the next problem is A, B, C are three vectors of equal magnitude. So these are unit vectors and these are of equal magnitude. So that means mod A is equal to, mod B is equal to, mod C is equal to some value, some letter will take. So fourth one solution, given mod A is equal to, fourth one, given that mod A is equal to, mod B is equal to, mod C is equal to, all the three are equal. So we'll take them as some x. Mod A, mod B, mod C is equal to x. And each of them is inclined at an angle of 60 degrees. That means angle between A and B is 60 degrees. Angle between A and C is 60 degrees. Here you are taking x. We are taking, so we'll write, say, angle between A and B is 60. A and C is 60. And angle between B and C is also equal to 60 degrees. These are all given. Okay, now you are also given one more thing. What is it? You are also given mod of A plus B plus C is equal to root 6. Root 6. So as I said, whenever you have mod A plus B plus C, You must square it and then simplify. So we'll write this implies mod of a plus b plus c whole square is equal to 6. Now what is the formula for mod of a plus b plus c whole square? Mod a square plus mod b square plus mod c square plus 2a dot b, 2a dot b plus 2b dot c plus 2c dot a is equal to 6. Now we'll find out mod a square is, mod a is x, so it is x square. Mod b square is also x square. Mod c square is x square plus 2 into a dot b value will write plus 2 into mod a into mod b into cos of angle between a and b, cos 60, cos 60 degrees. And then similarly these are also same, 2 into mod b into mod c into cos 60 degrees, and then plus 2 into mod c into mod a into that is also 60 degrees. Cos 60 degrees is equal to 6. Now what is cos 60? Sin 30, that is half. So that means this is 3x square, 3x square plus 2 into x into 1 by 2. Like this 3 times you should write, because this is also x, this is also x. So 2x into 1 by 2 plus again 2 into x into 1 by 2 is equal to 6. So 2 gets cancelled, 2 and 2 here also. So this is another x square, so on. So you will get 3x square plus x square, 2 and 2 gets cancelled. So again, so you will get 6x square is equal to 6. So that means x square is equal to 6. X square is equal to 6 by 6, that is 1. So that means x is equal to plus or minus 1. X is plus or minus 1. But modulus x is what? X is modulus of a. X is mod a. Mod a is always 1, positive, because modulus of any vector is positive. So mod a is equal to 1. So x you should take as only plus 1. Therefore, because mod a is greater than 0. So you'll write therefore mod a is equal to 1. This is the answer. So mod a is equal to 1. So like this we'll do. Now we'll continue with the next problem. Okay, next problem. This is again very important problem. And for any two vectors a and b. A and b are any two vectors. So show that 1 plus mod a whole square into 1 plus mod b whole square is equal to 1 minus a dot b whole square plus a mod of a plus b plus a cross b whole square. So when you look at the problem, it becomes it looks very complicated problem, but it is very simple. See, you know the concept of mod square, isn't it? So you write this is like a minus b whole square. This is like a plus b plus c whole square. Just expand, you know the formula, simplify, you will get the left hand side. So here we'll take the right hand side. See how simple it is. Right hand side will take that is mod of 1 minus a dot b whole square plus mod of a plus b plus c. C here is a cross b whole square. Now this is like a minus b whole square. So what is the formula? A square plus b square, a square plus b square minus 2a dot b. A dot 2ab means 2a dot b, that is 2 into a dot b. 2 into a dot b. Now again expand this. This is like a plus b plus c whole square. So that is a square plus b square plus c square. C square means a cross b whole square. A square plus b square plus c square plus 2a dot b plus 2a dot b plus 2b dot a cross c. So b dot a cross b, 2a dot b plus 2b dot c plus 2c dot a. C dot a means a cross b dot a. A cross b dot a. Now we'll simplify like this. This 2a dot b gets cancelled. So it is 1 plus a dot b whole square. A dot b whole square plus a square. A square is mod a square plus b square plus a cross b whole square is nothing but mod of a cross b. Mod of a cross b whole square. And this is 2 into, you will learn about this in scalar triple product in the next topic that we'll discuss. So we'll write this as box product B A B like this. We'll write like this. It is the scalar triple product A dot B cross C like that. So this is the notation. Okay. So for the time being, you just write like this, and this also A cross B dot A will write as A B A. This is called as the box product. You will learn about this in the next chapter, next topic. So now this, in the box product, when two vectors are identical, when they are same, the value is 0. Here B are same, so it is 0. A is same, so it is 0. Now for mod A cross B, you have the formula. We already derived this. Mod A cross B whole square is equal to A square B square minus A dot B whole square. We derived this as a theorem. So you will substitute this here, and then you will write box product of BAB is equal to 0, and the box product of ABA is also equal to 0. Now substitute the values. So it is 1 plus A dot B whole square plus A square plus B square plus, write the formula, A square B square minus A dot B whole square plus 2 into 0, and this is also 0. Now A cross A dot B whole square gets cancelled, and you will have 1 plus A square plus B square plus A square B square. A square B square. So this is nothing but A square is nothing but mod A square. B square is mod B square. And A square B square is mod A square into mod B square. Now just you can factorize and write it as 1 plus mod A into 1 plus mod B. So this is your left hand side. Hence it is proved. Hence it is proved. So we do like this. So here the points that you have to remember is expansion. It is direct expansion. A minus B whole square formula. A plus B plus C whole square formula. And so here the first these two gets cancelled. Then A cross B whole square you write as mod A cross B. Then write this is 1 dot and 1 cross. That is called a scalar triple product between three vectors. Triple product between three vectors. So if you have 1 dot and another cross between three vectors, that is called as the box product or scalar triple product. So in that scalar triple product, if two vectors are identical, its value is 0. So according to that property, we substituted the values, we simplify. So like this we do the problem. Now you take down the homework. You can try these homework problems, and then after that still we have vector areas. Vector areas of plane regions. So when you have any plane closed region like this, it will have some magnitude of the area, and then n cap is the unit vector perpendicular to the plane containing this, and the rotation should be in the clockwise direction. Clock moves like this, no? So it is the clockwise direction. When the boundary is in the clockwise direction and n cap is the unit vector perpendicular to the plane of this region, and if the magnitude of this area is A, then we define vector area as A into n cap, and we have some formulae. So we'll learn those formulae in the next period.